system are treated like a toy. Ideas are misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Talking about 0 point, the points lost on them. Kevin structures crumbling from the same old Sam. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard, injustice burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, rising shed boys. Benefactor boy, dreaming about the world begin to play. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice?
Alright, welcome, and welcome back to Beneficence TV Live for another mini-lab, for a special Thanksgiving mini-lab. So today we're going to be continuing the live stream I did last night, designing circuits. Today I want to focus on a program called Falstad. It's a circuit simulator, and apparently it's good at simulating the back EMF in the circuits that you're designing. And it also shows you, it has these neat little oscilloscopes on the bottom that show you the waveform, so you can keep track, which is very useful because we want to keep track of the waveform as we're designing our circuits. Specifically modifying the ABHA excitation circuit. What's going on, guys? Sorry, give me 1 second. I'm gonna load the chat up. Can't see it from here. I need to load it up on my laptop. There we go. Quintona, how you doing, Quintona? From Ireland. Do I have any products for sale? I don't have any products for sale yet, but we do have a products page with our intended product lineup. I can show you that if you want. But basically, the items that I want to push out first are small size coils, like this, and the lightning thief device, which is a modified ABHA excitation circuit, or a modified joule thief circuit. But before we put the lightning thief, before I put the lightning thief officially on the market, I wanted to solve the open circuit mode. And that's partly what we're doing tonight. Is what I'm going to do is take the simulator, I'm going to redesign, rather design and put the official circuit that we have running, and see if I can get that circuit running in the simulator. And then once that's running, we can further modify it, and I can use the simulator to kind of go in and see, oh, okay, if this idea works or not, which is pretty cool. It's going to be very useful. So it's not more, it's a less trial and error in that way, ordering random parts and trying things. So I can actually put them in the simulator now to see if they work. And we also have a modified Bedini circuit that I wanted to try. I don't know if we're going to get to it tonight, but it's a modified Bedini circuit by Shanjax, a viewer that emailed me. And you can find that link in the Phase 2 guide. There's a link in the beginning of the Phase 2 guide called Preliminary Guide. And in that one, it's all the way at the bottom. I'm not sure if we'll have time to go into that tonight. But this simulator program, I've been working with it a little bit. I know the basics of the user interface, so we're gonna try to rebuild our lightning thief circuit in the simulator and get it running. And once we have it running, we can then test some of our ideas. Specifically, I have an idea for a 2 transistor setup. I'm not sure if it'll even work, but we'll try it in the simulator. And also, there is an official Joule Thief circuit from somebody who designed one in this simulator on a video I found on YouTube that has a couple of modifications that I hadn't seen elsewhere. Specifically, they put a capacitor in parallel with the battery source. So I found that interesting, and we might try that. Hey, is Shanjax here? Hey, what's going on, Shanjax? Shanjax is in the house. Shanjax was the one who designed that modified Bedini circuit, and I honestly can't wait to build it. I think I have all the components. It's just a matter of time. So what I want to do, though, is modify that circuit so that my coil's inductance is accurate, because I don't think it's matching my coil's inductance right now. I had built a rudimentary circuit earlier and I didn't save it, but it's okay. We're still learning this program, so I'm gonna go over to the workstation. I'm gonna blow this up a little bit so you guys can see what's going on. All right. So this is the official Joule Thief circuit. I think we're gonna build this first and get this one running in the simulator and then work our way from there, because this has most of the components we're gonna need, plus a couple of interesting ones. Now you can see that they actually do include the high-speed diode, or not the just a diode, where our high-speed diode is placed on the positive rail output. Interesting, this is before the capacitor. I don't have a capacitor on the closed circuit mode, but yeah, we're gonna test all that in the simulator, so that's gonna be fun. So what I'm gonna do now is I'm gonna pop that out. There we go. Okay. So we have our power source. It's 12 volts. It doesn't say what the settings for the inductor are. I'll delete that. We don't need the switch. I'll keep the resistor. We need a capacitor. We might need another one of those. All right. That's right. They put a transformer here because that's what it really, technically in the simulator, it's the rodent coil is going to be acting as a transformer. So where is that? There we go. It's the wrong orientation. So let's add the right orientation. 1K is what we need. Okay, and that bridges the power source. To the channel A start and cap. This is the wrong orientation again. We're gonna add another capacitor in the right orientation. Just because having a clean diagram really does help. Shrink that down a little bit. I think that's about right. Oh, they put a 10 ohm resistor on the base for this one. We need a transistor. Here we go. NPN. Got a message from Shanjax. He says, for quick start, I just spam the BOM parts without regard for placement first, then arrange them roughly to fit the screen. Oh, okay, so you get a component list first, and then you basically pop all those components onto the screen and then arrange them. Okay, that makes sense. Honestly, I'm not really sure what these settings for the transistor do. Is this like the switch speed or something? Because that's really the only variable that I need to worry about, is how fast the transistor is switching. Let's see. Okay, so we have our collector up top and our emitter on the bottom. our emitter is going to go to ground, but it's also going to be part of the parallel connection for the load and cap. So that is down here. And this is 100 nanofarad, the capacitor. Let's change that right now. Hold on, let me do unifarad to nanofarad. That's what I thought it was, 0.1 microfarad. MF. Is MF the same thing as NF? I don't understand. Oh no, 100. I'm sorry. I was reading the wrong one. 100 nanofarad. Yeah, equals 0.1 microfarad. That's odd. Hold on. Unless I'm being retarded or something. So we have 100 farad. I guess it's the same. Yeah, I guess it's the same. Yeah. Interesting. I guess they use MF instead of UF sometimes. Is that what's going on? Is that why I'm confused? Either way, we'll try it. Oh, Shanjek says BFE is the amplification factor, base current to collector current ratio. Okay. So that ratio can hopefully allow us to add some variation to the switch speed if we need to change it or make it faster if it's not fast enough. We need a diode here. That is not a diode. There you are. That's 10 microfarad capacitor. Back to the emitter for that one, and then we have another extension in parallel with the diode, or I'm sorry, with the neon lamp. But this one has an LED, it looks like. So let's see. Outputs. Let's do the LED. And then we just need to connect the second channel for the coil and then the resistor. Millifarad. Okay, so in the diagram here, it shows 100 nanofarad. I'm trying to get that value into this simulator, and I'm not. I don't know if it's like a simple error that I'm making with the conversion, but I'm not able to get it to go down to 100 nanofarad. There it is. I have to put the okay, so I have to put the measurement symbol in front or behind the number. Okay, that makes sense. All right. Now we're going to gonna add a wire here. That goes like that. And this connects to channel B start. And then channel B end connects right to the collector. I don't like the way that looks. Yeah, that's a little better. Oh, and it's running. Okay, so we have it running. It doesn't look like it's switching unless we can't see it. Let me see if we can slow it down. Is it actually switching? And where's the O scope? How do I view the O scope? Oh, there we go, scopes. It won't let me view the scopes. Yeah, the scopes menu list is all grayed out. But let's slow it down. It doesn't look like it's switching, but it's turning on. Let's see if that's what the video shows current. Yeah, the base isn't getting any current. So what's going on here? The base isn't getting any current. We might have to, here, let me see if we can increase the power and that help. That might help. 15 volts. No. These are red. I'm not sure what that means. This is bad connection. Oh, hold on. Maybe it's not connected fully. Let's try that again. Let's put another resistor in there. There we go. Maybe that's what happened. Maybe it just wasn't connected all the way. Down to 10. And this isn't connected. It looks like bad connection there. Interesting. I'm not understanding. Huh. Let's see. So we have 2 bad connections there. And only 1 bad connection there. See what Shanjax has to say. Yeah, bad connection. So I fixed the bad connection between the base resistor. But I'm not really sure how to fix the bad connections between the resistor, the 1K resistor, between the positive and channel B. Oh, the white dots are available connection points. Okay, let me see if that helps. White dots are available connection points. Hey, there we go. He solved it. Thank you. I appreciate it. I wouldn't have been able to do that if you weren't here. I've been sitting here forever trying to think this through. Okay. Yes, we're getting a little bit of, just a tiny bit of movement. Not that much, though. There we go. I increased the current speed. So it's running. It's running. And it's dumping into the capacitor, it looks like, very slowly. It's interesting because it doesn't look like anything's dumping into the capacitor. At least the current's not flowing into the capacitor like it is in the video, but either way, it does look like it's working. So that's good. All right, so we have a working model and a rudimentary understanding of the simulator. Let's see if we can create our modified, or Michel Morel's modified Joule Thief circuit. You said 100 nano. Oh, yeah, that's right. That one is red, too. I didn't even notice that. Good catch. All right. Let us rewire that. That's why. Nice. There we go. looks like it's working. I don't see any more red dots, or I'm just wondering, how do I enable the scope? The scopes are all blocked out. I really need to be able to monitor the waveform. Ooh, we got guys, we got European resistors. Ooh la la. All right, so we're going to grab all this and rearrange it. Because mine has a 1K ohm resistor and a potentiometer, so we're going to take that. And we're going to add a pot. And then we're going to smoke some pot. I might make some mac and cheese in a minute. So I'm starting to get a little hungry. Where is the potentiometer? Oh, there it is. There we go. So that's our transistor and pot. And this is going to be a 1 mega ohm. So I believe, no, that's not enough zeros. There we go. Now our cap is going to be 0.1 unifarad. So we're going to try it with and without the parallel cap. 0.15. I'm sorry, not unifarad, microfarad. I don't know why I always say that. So is that right? 150 nanofarad. Okay, yeah. So 0.15 microfarad.
right, now the thing with our coil is that we have, for the closed circuit method, I haven't gotten verification on how Michelle did the open circuit with the PCB, but with the closed circuit we know that channel A start is connected to channel B end. So we have to go in and connect that like that, and then this gets put on the power rail, positive. Yep, okay, we got 12 volts on the source. Okay, and the emitter is going to go to ground. And then channel B start is going to go to the collector right here. All right, and that is our modified Joule Thief circuit. Just double check the connections. Channel B and channel A. Channel B start, collector. Oh, we got the 1K ohm pot, base, emitter. All right. Ooh, look at that. Look at that. I don't know. Does that mean it's switching really, really fast or really, really slow? You said outputs, right? Let's see. Outputs. Oh, here we go. We got a wattman and or a watt meter. Where's a oscilloscope? Scope probe. Is that it? Actually, let me take a look at your diagram to see how you have the scope set up, because obviously I have to set it up somehow. But I don't know. What do you think? Does this look like it's working the way it should? It's hard to tell without the waveform, to monitor waveform to see what we're looking at on the scope. Here, let me take this actually off real quick before we do that. Interesting. Okay, so we really need to probe and see how much power it's getting. We can do a real quick watt meter real quick. Watt meter. might actually be simpler. Let's see. Drag. Go. 2.3 volts. And without the capacitor there. Still 2.3, so it didn't change it at all. So obviously the capacitor here is the wrong value. And also, we need to change the henries to match my coil, which I thought it was either 5.5 millihenries or 55 millihenries. Total inductance, which would mean it would be half that per channel. So let's try 55 millihenry. Raise the voltage slightly. Okay. 5 Henry. Oh, maybe just not having the capacitor raise the voltage. That's weird. Let's put it back down. It was at 4 Henry. Yeah, it's the same. So it must have been the capacitor. Let's put that back on there. Oh, there's no difference. It's weird. Wonder why it was down slightly a minute ago. Oh yeah, forgot about the pot. Let's try adjusting the pot, because that actually plays into it as well. So we have to adjust this potentiometer resistance here. There we go. Okay, yeah, because this pot's going to be all the way down for our coil to be working. There, now you see it's starting to switch. There we go. So I'm starting to figure this out. Now we need 55 millihenry. I think that's what I'm at. But there's no way we're getting that kind of voltage. We're getting a lot more voltage. Like at least 10 times voltage output. Oh, here we go. Oh, it's starting to increase because of the capacitor. Okay. Oh, I see. Because I have the speed set. So it's going to increase as the capacitor charges up. I believe that's how it works. Let me see. Simulation speed. Yeah, you see it's charging up now. Very slowly. This is 10 microfarad though. We want to lower that down to 150 nanofarad. And that is actually the wrong value. Interesting. Well, we know that's the value for the open circuit. So if we assume that, let's work our henries backwards. So 5 Henry, 5 millihenry. Yeah, see, it's starting to charge a little bit more now. So my inductance might be really, really low. Let's go lower than that. Let's go 0.5 millihenry. Oh, looks like about the same speed. Let's go back up to 5 Henry. Yeah, it's not charging at all. So we're going back down to, what were we at, 55 millihenry? When the capacitor was charging a little bit. Mm, 5 millihenry. Yeah, I don't see it charging at all. Maybe it's fully charged and you need to discharge it somehow. I'm not really sure how the simulation works. Oh, reset? I don't know if I should do that. Reset. Oh, there we go. Okay, so it's pushing a little bit. Change that to 55 millihenry. It's not pushing at all now. 5 millihenry. I believe that's what my coil is, about around 5 millihenry or 5.5 millihenry of inductance. Okay, yeah, I'm just gonna have to discharge it again. 55M, because I want to be sure. Yeah, it's not pushing at all. But at 5 millihenry, it starts to push just slightly. So it looks like we're getting close to that frequency. Maybe we're not. Maybe 0.15 microfarad isn't good for this circuit. So let's try changing this capacitance value, messing with it a little bit, and see if we can get that flow rate to charge up the capacitor faster, because it's like barely charging. I don't know if that's because it's such a small capacitor and it doesn't need to charge that much and it's just really slow. But either way, we're gonna mess with this value and see what happens. Let's go down. Let's go down to 100 nanofarad. nanofarad. Holy shit. Hold on. It looks like it's... Did I just see something? Oh, it's like wiggling. Either that or it's going super fast. Hold on. Alright, let's go down more. Let's do 1 nanofarad. It might have been just a glitch. .1 nanofarad. So 100 picofarad. Oh, there we go. Okay, so it's moving when I put it really fast. You can see it. You can actually see it moving. but it's really slow. Should add things to a scope. Yes, we're trying to figure out how to do a scope next. So once I figure out this capacitor situation real quick, I'm gonna try the scope. I need to look at Shanjax's circuit as reference. Let's see how he has it set up. I wish there was a slider. Maybe they have a variable capacitor I can put in here. I wish there was like a slider that I can use to determine the optimum capacitance. I could always bust out the equation. I could always do that. We'd have to see what frequency we're running at though. So let's get the scope. Let's get the scope working. Okay, so I'm going to open so this is the preliminary guide. I'm going to put the link in chat for you guys again so you have it. Alright, so that's the preliminary guide for the coils and my research. At the very bottom, this is the Falstad link provided by Shanjax. This is his custom Bedini circuit. Very impressive work. I'm really excited to actually get it working, but for now we're going to use it as reference. To see how he has his scope set up. So, alright, so I see remove, undock scope, max scale, stack, combine, scope. Yeah, see, these are not grayed out at the top. That's weird. Maybe I could just copy and paste mine. I hope I can. Yes, I can. Ooh. Oh, that's cool. Okay, so I'm sorry. I'm going to have to ooh, that's not what I wanted to do. Let's take this. Okay. Oh, this is the okay, you get the scope from the AC source. Okay, that makes sense. In the square wave. Okay, the function generator or whatever. Alright, so we're gonna put that on here. It says 3 bad connections. Something's bad here. Right here. Wow, this whole thing is red. Let's reset that. What is going on here? go. Oh, there we go. It's still... Oh, the resistance... Yeah, it's still red. This is one bad connection. Where's the other bad connection? It's got to be right here. But it's not. Huh. That's so weird. Maybe we'll try copying the scope from this one. That's weird because it doesn't give me the access to this. Yeah, now it's grayed out too, which makes me wonder if there's a setting over here that I'm not seeing. Okay, so we're gonna put this back the way it was, and there's got to be a setting over here that I'm not seeing. Options. Ooh, we can put a spark gap in there. That's so cool. Let's get one of these babies out here. Marx generator, solitude generator, Tesla coil. Oh, that's what that is. No, I don't want it. Yeah, never mind. I thought that was just a component, not a whole schematic. Huh. Okay, well... I'm stumped. I'm gonna go and Google it. Oh, right-click a component in view and scope. Oh, is that what you do? Let me see. Oh, in the context menu of the right... I'm so stupid. View and new scope. There we go. I'm like, what the fuck? This should be like basic shit. Okay, there we go. That's why. All right, so we have a look at the capacitor. A couple of spikes. It's only getting noise when I adjust it a little bit. That's weird. So it must be the wrong value. So let's scope out. Let's close this. Let's scope out the transistor. We have that in the base and the collector. So that's the capacitor. Let's try to adjust the capacitance again. Let's try 500 nanofarad. So when we adjust the resistance, the capacitor, I don't know. If the yellow line is the capacitor energy, then it's only spiking when I adjust the resistance of the potentiometer, which is weird. Oh, hold on. Something jumped up here. You see that line jumped up? I'm at 10 farad. Interesting. Okay. Yeah, and we go back down. Okay, so we're at 10 farad when that starts climbing. Let's try 100 farad. So we might have to increase our capacitor for this. So we're at 0.15 microfarad. That was 10 farad. And then see, put in 10 farad and all of a sudden it starts spiking or climbing slowly. At least it did. What's going on here? And now it's not climbing anymore. It seems to be climbing now at 1 farad. Let's go back up to 10 farad. That's weird. Hold on, so what did I have it there? I swear it was 10 farad when I was climbing like that, right? Let's try resetting it. Maybe it fully charged. That's why. Yeah, so we have them climbing now at 10 farad. Okay, stop. We're gonna change that to 100. Reset. It's climbing even faster. Holy shit. Okay. Yeah, look at it. It's okay. It's charging up now. Oh, wow. Look at this. It's actually charging the fucking capacitor now. That's good. That's what we want to see. But I don't think it's lighting the I don't think it's lighting the LED. Hold on. Take that out. Yeah, it's not lighting the LED. So that's a problem. Oh, there we go. Oh, so it's okay, so it's charging up slowly. Slowly. Okay. That's why. All right, we're figuring it out. Let's change that to 500 farad. Back down. I think it was charging faster at 100. Yeah, was charging faster at 100, so let us go down to 50. Okay, 1 farad. Charging way faster. Okay, we're going to continue to go down. So let's do 0.1. No, we need unifarad. Microfarad, sorry. I don't know why I keep on saying una. It's microfarad. Oh, wow, yeah, so that's charging a lot faster. Okay, yeah, so we're in the wrong capacitance value altogether for our circuit here. At least for the closed mode. Let's go to 500 microfarad. A little bit faster. It's right around here. It's going to be really hard unless we, I don't know, maybe time it with a timer or something and see how long it takes for it to fully charge up. Let's see. Let's do 100 micro. Micro. Seems like it was a little bit faster at 100. I'm going to actually take a quick break, and I'll probably ask ChatGPT if it has any suggestions, and I'll also run that equation for the LC circuit to determine, see if we're in the capacitance range for our inductor and frequency. So, all right, I'll be right back, guys.
Yeah, Shanjack just said the cap is hogging the current. The LED won't light until it's fully charged, right? Until that threshold is reached. So that's what I kind of observed. I'm like, oh, okay, now I didn't think it before. But that's why we run the simulation, so we can understand how the circuits work. Thank you, Shanjack, for being really great at showing us how to use this program. It's awesome that we got this working.
Why live in isolation? Why guard your self-control? Why embrace complication? Why bear a living soul? My eyes see no salvation. My eyes see your troubled soul. My eyes see your fleeting romance. My eyes see your bloody soul. I'll try to stop the voices, but now they come and go. I'll try to fix the problem, but now I've done a hole. I'll try to find my reason to no bitter end I'll fail. I'll try to find the reason until finally killed. Falling away, my mind is torn to prey. Falling away, just for every day. My mind is fall away. I try to stay my mind is, but now they come away. I try to fix my problem, but now I've got away. I try to stay my mind is, to no bitter end all the way. I try to stay my mind is, but I won't ever tell. I reach out for connection, lost to sight in this web of imperfection. My shadow side, I'm drifting into the unknown as I wade through the darkness. Whispers rise and shatter the air. Strings of fate are pulled too tight to suspension. Across the horizon, a tangled time. I search for solace in the chaos. I'll try to hold the pieces, but they slip through my hand. I'll try to fight the shadows, they still make demand. I'll try to rise from ruins, but I'm drowning in the sand. I'll try to find my way through till I understand. I'm searching for dimension and pain inside. In this maze of his perception, trying to find. I'm riding on the edge of night. I can't deny as I walk the thick shadow, running for the sky. The echoes of the broken in the fracture of the silent lyrics, in the labyrinth of my mind, suddenly unwound. I'll try to quell the thunder, but it echoes deep inside. I'll try to light the tunnel, the shadows won't subside. I'll try to heal the fracture, hold together all that's mine. I'll try to paint the silence and the stars align.
Feel the pulse, divine sensation. Everyone needs just a little foundation. Feel the pulse, divine sensation. Everyone needs just a little salvation. majestic moments in cosmic flight. Holding on to stars of starlight. There's a light within the dark waves, guided by echoes of ancient ways. Unify our reflection. With everything there's a connection. Feel the pulse, divine sensation. Everyone feels the goodness of our invitation. There's a light within the dark ways, guided by echoes of ancient ways. Unify our reflection. With every beat there's a connection. Feel the pulse, divine sensation.
Alright, I'm back. I had to ask ChatGPT a couple of questions because this coil doesn't act like a normal transformer. I'm wondering, because it's obvious the frequency being utilized in this simulator is a lot lower than the frequency that we need to be at. So I'm wondering if we need to adjust something, because the coil doesn't really act like a normal coil. It does amplify voltage. It steps it up quite a bit compared to a normal coil. So I'm also going to adjust the circuit to see if we can put the capacitor on the battery. See if that helps at all. That might give us some kind of improvement in efficiency or something. I don't know. We'll run the simulations and find out. that's why. Maybe. Give me 1 second. trying to find where the frequency is being shown. I don't see it anywhere. Interesting. Look at what happens when I swap the secondary polarity. So the capacitor isn't fucking moving at all, right? Well, let's reset it. Let's reset it. Okay, so the capacitor isn't moving at all. We go into the transformer properties and we swap secondary polarity, and look what happens. It gets a little bit of an overload on the base, but it starts charging the capacitor. And then we can swap it back over. Interesting. Unfortunately, we can't see, it stabilizes, but we can't stop and run it like that. We have to run it the other way. Interesting. And the reason why I did a 1 to 10 ratio is because, you know, even though it's a 1 to 1 ratio of winds for the coil, it does step up voltage times 10. And that's what we've seen even with the closed circuit mode. So yeah, that's what we're running with. We're gonna have to, you know, put that in there, and that might give us a more accurate frequency for our tank to find the perfect tank, which is the capacitance value. We're just trying to confirm because it might not be 0.15 microfarad for my system for at least this circuit. We know for the stereo amp, true, like that produces a true sine wave, or if you have like a function generator, anything that produces a true sine wave output into the coil, then the 0.15 microfarad works. But this closed circuit is a little bit different, so I might have to adjust the capacitance. Oh, and we're gonna try to put the capacitor on the battery too, so let's do that.
So interestingly enough, the original diagram for this jewel thief that I was looking at does have this swapped. So let's see if we can get that to work real quick. That might be our problem. Oh no, it's stabilized. It just took a minute. Awesome. Okay, cool. Alright, so let's leave it at that and then put a capacitor on the battery. So what I just did was added another vortex coil to the same output using the same battery source, and I've actually done this. I've even done it without the coil being connected to the power source, just wirelessly inducing the electricity by placing the coil on top of the primary coil. So it's like a pickup effect. That's pretty cool when you place the coils on top of each other when they're in resonance. So that's pretty cool. Now we have a visual diagram to work with for that dual thief setup. Let me save this because that's pretty important diagram right here. So the only real difference from the ideal version that I'd like to see is the second coil would not be directly connected to the power source. The second coil is getting its power directly from the induction, from sitting on top of the primary coil, so it acts as a pickup coil. And it wirelessly induces the electricity that way. And it's enough to power the system. So that's pretty cool. It doesn't seem to affect the source drain at all. So given that it doesn't, or assuming that it doesn't affect the source drain, then it's, you know, basically free extra energy that's not being used. I'm not saying it's over unity, but it's energy that would otherwise be just fucking wasted in any other system. I might not do any actual experimenting tonight. I might wait till tomorrow because I'm getting some new parts in, and then we'll have some fun. Hopefully we'll get something set up tomorrow once my new transistors get here. So I'm going to wrap it up. I might come back on, play some video games in a little bit before I call it a night. So thanks for tuning in. Have a good night.